Hello there, and welcome to the Sleep with Stories channel. I'm so glad you found your way here. Maybe you've had a restless day, or maybe you're someone who finds peace in the quiet echoes of distant worlds rather than the noise of this one. Tonight, we aren't just looking at the night sky. We are descending toward the rusted, windswept plains of our neighbor, the red planet. Mars is a world of silent ghosts, a place that once held rivers, perhaps even life, but now sits in a cold, dusty slumber. Beneath its crimson surface lie riddles that have puzzled humanity for centuries. Tonight, we explore the first 10 of these cosmic enigmas. You have nothing to do but listen. Let your breathing slow, let your body sink into the bed, and let's begin our journey across the Martian sands. The methane burps. One of the most persistent and frustrating mysteries of Mars is the presence of methane in its atmosphere. On Earth, the vast majority of methane is produced by living organisms, cows, microbes, and decaying vegetation. For decades, our rovers and orbiters have detected burps of methane gas rising from the Martian surface. What makes it a mystery is its inconsistency. It appears in plumes, lingers for a few months, and then vanishes without a trace. If it were coming from geological activity, we would expect a steady stream. Instead, it feels like something is breathing. Is it a sign of microbial life huddled deep in the warm, damp crevices underground? Or is it a strange chemical reaction involving olivine rocks that we don't yet fully understand? The two-faced planet. If you were to look at a topographical map of Mars, you would notice a jarring, violent asymmetry known as the Martian dichotomy. The northern hemisphere is smooth, flat, and sits several kilometers lower than the rest of the planet, resembling a dried-up ocean floor. The southern hemisphere, however, is a rugged, crater-scarred highland with a crust that is significantly thicker. Scientists are baffled by this split personality. One theory suggests a colossal impact from a protoplanet the size of Pluto struck the north, melting the crust into a smooth basin. Another theory posits that ancient plate tectonics or mantle plumes shifted the planet's internal weight. Why one half of the planet looks like a peaceful sea and the other like a battlefield remains one of Mars' oldest secrets. The ghost of a global ocean. We see the evidence everywhere. Dry riverbeds, deltas, and minerals that only form in the presence of water. Most scientists agree that Mars was once blue, but the mystery lies in the where and the when. Some climate models suggest that ancient Mars was always too cold for liquid water, meaning the rivers might have been carved by brief, violent periods of volcanic melting rather than a stable climate. More importantly, where did all that water go? While much of it escaped into space after the planet lost its magnetic field, recent data suggests a massive amount, perhaps an entire ocean's worth, might be trapped as ice or chemically bound into the rocks deep beneath the surface, waiting in a frozen subterranean tomb. The mystery of the missing magnetic field. Billions of years ago, Mars had a dynamo, a spinning molten core that generated a global magnetic field, much like Earth's. This shield protected its atmosphere from the harsh solar wind. Then suddenly the dynamo turned off. Without its magnetic shield, the sun literally stripped Mars of its air and water. But why did the core stop spinning? Some believe it cooled too quickly due to Mars' smaller size. Others wonder if a massive asteroid impact disrupted the planet's internal heat flow, effectively killing the planet's heartbeat. Today, only small patches of crustal magnetism remain, ghostly remnants of a shield that once guarded a living world. The recurring slope lineae. On the steep walls of Martian craters, dark, finger-like streaks appear during the warmest months and fade during the winter. These are known as recurring slope lineae. For years, the leading theory was that these were flows of salty brines, liquid water seeping out of the ground. However, more recent observations have suggested they might be dry flows of sand and dust triggered by temperature changes. The mystery persists because some of these streaks show chemical signatures of hydrated salts. If it is water, it means Mars is still leaking liquid from hidden reservoirs. If it's just sand, it reveals a strange, fluid-like behavior of Martian dust that we have yet to replicate in a lab. The face and the pyramids of Cydonia. While science eventually explained the famous face on Mars as an optical illusion caused by shadows on a mesa, the region of Cydonia remains a focal point of mystery for many. Beyond the face, there are structures that look remarkably like five-sided pyramids and a city-like layout of mounds. While geologists argue these are just the results of erosion and volcanic activity, the mathematical symmetry of their placement continues to spark the imagination. Are they truly just natural hills? Or are they the eroded, dust-covered ruins of a civilization that perished when the atmosphere bled away? The high-resolution photos show rocks, but the mystery of our own pattern recognition keeps the legend alive. The Martian meteorites and ALH 84001. We don't have to go to Mars to touch it. Mars has come to us. Several meteorites found in Antarctica have been confirmed to be Martian rocks ejected by impacts millions of years ago. The most famous, ALH 84001, contains tiny, rod-shaped structures that look exactly like fossilized nanobacteria. In the 1990s, this was hailed as the first proof of alien life. Later, skeptics argued these structures could be formed by non-biological volcanic processes. To this day, the scientific community is split. Did this rock carry the fossilized remains of ancient Martians across the void? Or is it just a clever trick of geology meant to mimic the shape of life? The Great Dust Storms. Mars is home to the largest dust storms in the solar system. Occasionally, these storms grow so large they envelop the entire planet in a red haze for months, hiding the surface from our telescopes. The mystery is what triggers these global events. Why do small, localized dust devils suddenly merge into a planetary monster? These storms are powerful enough to kill rovers, as they did with the Opportunity rover, yet the Martian atmosphere is so thin that the wind has very little push. The physics of how such a thin air can lift enough dust to choke a whole world remains a subject of intense study and atmospheric modeling. The origin of Phobos and Deimos. Mars has two tiny moons, Phobos and Deimos, which look more like lumpy potatoes than spheres. For a long time, we assumed they were just asteroids captured by Mars' gravity. But their orbits are almost perfectly circular and aligned with Mars' equator, which is nearly impossible for captured asteroids to achieve. This suggests they were born from Mars itself, perhaps the remains of a giant impact that threw a ring of debris into space. However, their composition is primitive, matching asteroids from the outer solar system. How can they be made of asteroid material but have the hometown orbit of a moon born from a collision? They are the immigrant moons with native paperwork. The Labyrinth of Night. Located at the edge of the Great Valles Marineris Canyon system is a vast, chaotic network of deep, steep-walled valleys known as the Labyrinth of Night, Noctis labyrinthus. It is one of the most complex geological features in the solar system. The terrain is a maze of collapsed crust, intersecting canyons, and strange pits. While it was likely formed by the bulging of the nearby Tharsis volcanic region, the sheer intricacy of the maze is haunting. Some believe the valleys were widened by retreating glaciers or even massive floods of groundwater. It is a place of perpetual shadow and thin, freezing air, a labyrinth that holds the secrets of how the Martian crust cracked and crumbled under unimaginable stress. The Martian spiders. As the spring sun begins to warm the southern polar ice caps, strange, dark, spindly shapes appear across the landscape, looking remarkably like giant arachnids crawling over the dunes. These spiders of Mars are not biological, but they are evidence of a truly alien geological process. Mars has an atmosphere rich in carbon dioxide, which freezes into dry ice during the winter. When spring arrives, sunlight penetrates the translucent ice sheet and warms the dark soil beneath. This heat causes the bottom layer of ice to turn directly into gas, building up pressure until the ice cracks. The pressurized gas geysers upward, carrying dark dust from the ground and depositing it in these sprawling, spindly patterns. The mystery lies in the scale. These features can span hundreds of meters, and we have nothing like this cycle of explosive sublimation on Earth. The bottomless holes of Arsia Mons. On the dusty slopes of the massive Martian volcano Arsia Mons, orbiters have captured images of perfectly circular, pitch-black pits. These aren't typical impact craters with raised rims. They are sheer, vertical shafts that drop into total darkness. Some of these holes are over 100 meters wide, and despite our best imaging technology, we cannot see the bottom. Scientists suspect they are skylights, places where the roof of an ancient lava tube has collapsed. The mystery is what lies within these subterranean caverns. Because they are shielded from the sun's harsh ultraviolet radiation and the freezing winds of the surface, they might be the most habitable places on the planet. Could these dark voids hold the last remnants of Martian water? Or perhaps the elusive signs of life? The blue sunset. If you were standing on the surface of Mars as the day came to an end, you would witness a scene that feels like a photographic negative of Earth. While our sunsets are famously red and orange, a Martian sunset is a haunting pale blue. This inversion is caused by the fine dust in the Martian atmosphere. On Earth, our thick atmosphere scatters blue light, leaving the reds to dominate the horizon. On Mars, the dust is just the right size to allow blue light to penetrate the atmosphere more efficiently than other colors. The sun itself appears smaller and colder, surrounded by a blue halo that fades into a murky pink sky. It is a reminder of how the very air of a planet dictates the colors of its most beautiful moments. The moving dunes of Patera. For a long time, astronomers believed that the winds of Mars were too weak to move the planet's vast sand dunes. They thought the dunes were fossil structures, frozen in place millions of years ago when the atmosphere was thicker. However, recent high-resolution images have shown that the dunes in regions like Patera are actually migrating. Some ripples move several meters per year. The mystery is the physics behind it. In an atmosphere only 1% as thick as Earth's, it should take incredibly high wind speeds to lift a single grain of sand. Yet the dunes march on. This suggests there are atmospheric triggers or perhaps electrostatic forces at play that we are only beginning to comprehend. The ghostly clouds of dry ice. High in the Martian mesosphere, nearly 100 kilometers above the surface, thin, wispy clouds occasionally form. On Earth, clouds are made of water droplets or ice crystals, but these Martian clouds are often composed of pure carbon dioxide ice. They form at altitudes where the atmosphere is so thin and cold that the CO2 freezes instantly. The mystery is how they form at all. Clouds need nuclei, tiny specks of dust, to crystallize around. At such extreme heights, there shouldn't be enough dust to support cloud formation. Some researchers believe these clouds are seeded by space dust from meteorites burning up in the atmosphere, creating a delicate, crystalline bridge between the planet and the void of space. The Medusae Fossae mystery. Along the Martian equator lies a massive, wind-eroded formation called the Medusae Fossae. It is a soft, easily erodible deposit of dust and ash that stretches for thousands of kilometers. Radar soundings have revealed that the deposit is incredibly deep, but they also showed something confusing. The region appears to be electrically transparent. This has led some scientists to propose that the formation contains massive amounts of water ice buried beneath the dust. If true, it would be the largest deposit of water near the equator, where it shouldn't be able to survive. How did such a massive volume of ice, or perhaps volcanic ash with strange properties, end up in one specific giant pile? The missing Xenon 129. When scientists analyzed the Martian atmosphere, they found a strange abundance of xenon-129. On Earth, this isotope is a byproduct of nuclear fission. Its presence on Mars has led to some of the most fringe and controversial theories in planetary science, including the idea that large-scale nuclear events occurred in the Martian past. While the mainstream scientific explanation involves the natural decay of iodine-129 in the planet's early history or the stripping of lighter isotopes by solar winds, the signature remains an anomaly. It is a chemical scar in the atmosphere that points to a violent, energetic event in the distant past that forever changed the composition of the air. The Great Basin of Hellas. The Hellas Planitia is the largest visible impact crater in the solar system, a basin so deep that the atmospheric pressure at its bottom is high enough to theoretically allow liquid water to exist for short periods. The mystery of Hellas is not just its size, but its influence on the planet. The basin is often shrouded in frost and clouds, and it seems to act as a weather machine, generating its own local wind patterns. Because the floor sits 7 kilometers below the surrounding terrain, it is an alien world within an alien world. We have yet to land a probe there, leaving the deepest, highest pressure environment on Mars a total blank spot in our direct exploration. The disappearing polar caps. Every winter, the Martian polar caps grow as carbon dioxide snows out of the atmosphere, and every summer, they shrink. But beneath the seasonal dry ice is a permanent cap of water ice. In the south, this permanent cap is oddly offset from the actual geographic pole. Furthermore, we've discovered that the southern cap is currently undergoing a period of rapid erosion, with pits in the ice expanding year after year. Is Mars coming out of an ice age? Is the planet currently warming up? Because we have only been observing Mars for a few decades, we don't know if this is a normal cycle or a sign of a planet-wide climate shift that is happening right before our eyes. The Martian white rock. Inside a crater in the Martian tropics sits a feature known as the white rock. It is a cluster of bright, white eroded ridges that stand out starkly against the red dust of the surrounding plains. For years, scientists thought it was a deposit of salt from an ancient lakebed. However, spectral analysis showed no salt. Instead, it appears to be made of the same dark volcanic rock as the rest of Mars, but coated in a mysterious, highly reflective material or weathered in a way that creates a brilliant white appearance. It remains a glowing enigma, a beacon of white in a world of red that defies our typical understanding of Martian mineralogy. The monolith of Phobos. On the surface of Mars' largest moon, Phobos, there is a solitary towering boulder that stands completely alone in a barren, relatively flat area. Known as the Phobos monolith, this giant slab of rock is roughly the size of a tall building and casts a long, sharp shadow across the moon's airless gray soil. Because Phobos is a lumpy, irregular world with very little gravity, the presence of such a massive, upright structure is geometrically jarring. While geologists believe it is a piece of ejecta, a fragment of rock thrown up by a distant impact that happened to land on its end, its isolation makes it look like a deliberate marker. It remains one of the most visually striking anomalies in the local solar system, a lonely pillar standing guard over a moon that is slowly spiraling toward its doom. The strange grooves of Phobos. Phobos is not just famous for its monolith. Its entire surface is covered in a series of mysterious, parallel grooves and furrows. For decades, scientists thought these were fractures caused by the massive impact that created the moon's largest crater, Stickney. However, closer inspection revealed that the grooves don't all radiate from that crater. A newer, more haunting theory suggests that these grooves are stretch marks. Because Phobos orbits so close to Mars, the planet's gravity is literally pulling the moon apart. These furrows may be the first signs of the moon's structural failure. Eventually, Phobos will be shredded by tidal forces, and the debris will form a dusty, sparkling ring around Mars, leaving the planet with a halo like Saturn. The glass dunes. In certain high-resolution infrared images of the Martian surface, astronomers have found dunes that seem to be composed of a substance that shouldn't exist in such quantities. Glass. These are not the typical basaltic sand dunes we find elsewhere. They are rich in silica, similar to the glass created when lightning strikes sand on Earth or when a volcano erupts violently. The mystery lies in the formation. Mars does not have the intense thunderstorms required for lightning-fused glass, and its volcanoes are mostly basaltic. Some researchers wonder if these dunes are the result of ancient, massive meteorite impacts that flash-melted the ground, or if there is a form of cold volcanism we haven't yet identified that produces glass-rich ash. The mystery of the Martian ice worms. In the early 2000s, satellite images of the Martian North Pole revealed strange, translucent, tube-like structures winding through the canyons. Dubbed glass worms or ice worms by the public, these features looked like colossal, ribbed tunnels weaving in and out of the sand. Science eventually provided a more grounded explanation. They are likely a form of sand dune created by unique wind patterns within deep canyons. However, the mystery isn't entirely solved. The way these tubes maintain their perfect, ribbed symmetry over kilometers is unlike any dune system on Earth. They look less like piles of sand and more like a biological or architectural nervous system, frozen into the crust of the planet. The sound of the Martian wind. When the InSight lander touched down on Mars, it carried sensors sensitive enough to detect the vibrations of the wind. For the first time, we heard the sound of another world. The mystery, however, is the frequency. Martian wind doesn't whistle or howl like Earth's. It has a low, bass-heavy thrum. Because the atmosphere is so thin, it carries sound differently, muffling high pitches and emphasizing deep vibrations. It sounds like a low-frequency hum that vibrates in your chest. This ghostly, acoustic environment means that if you were standing on Mars, a storm could be raging around you, but it would feel strangely silent, a quiet violence that defies our sensory expectations. The disappearing nitrogen. Nitrogen is a key ingredient for life, and on Earth, it makes up the bulk of our atmosphere. On Mars, however, nitrogen is incredibly scarce. While some of it escaped into space along with the oxygen and water, there is a massive missing portion of nitrogen that models suggest should still be there. This has led to the theory of sequestration. Scientists believe the nitrogen might be hidden within the Martian soil in the form of nitrates. But so far, our rovers have only found tiny traces. If the nitrogen isn't in the air and it isn't in the surface rocks, where is it? The absence of this life-giving gas is a major hurdle in understanding whether Mars ever had a truly robust biosphere. The layered mysteries of Mount Sharp. At the center of Gale Crater sits Mount Sharp, a mountain 5 kilometers high. What makes it a mystery is that it shouldn't be there. Usually, craters have a small central peak, but Mount Sharp is a giant mound of layered sediment that is taller than the crater's rim. It's as if someone filled the crater with layers of mud and dust over billions of years and then carved the rest away. Each layer of the mountain represents a different era of Martian history. Some were formed in deep water, others in dry deserts. The mystery is the unconformity, the missing chapters in the rock record where millions of years of history seem to have been erased or never recorded at all. The Martian blueberries. When the Opportunity rover landed in Meridiani Planum, it found the ground covered in billions of tiny, grayish-blue spheres. Astronomers called them blueberries. These are hematite concretions, small balls of mineral that, on Earth, typically form in standing water. The mystery is their sheer abundance and perfect distribution. They are scattered across the plains as if they were rained down from the sky. While they prove that the area was once soaked in water, The exact chemical mechanism that created billions of perfectly uniform spheres over such a vast area remains a subject of intense debate among geologists. The transient liquid water of the equator. Standard physics tells us that liquid water cannot exist on the surface of Mars. It would either freeze instantly or boil away into gas due to the low pressure. However, data from the Curiosity rover suggested that at night, the soil at the equator becomes humid enough that salts in the ground can suck moisture out of the air, forming tiny droplets of brine, salty water, in the top centimeters of the soil. These droplets would vanish as soon as the sun rose. This means that even in the driest, most sun-scorched parts of Mars, there may be a heartbeat of liquid water that appears and disappears every single night, hidden just beneath the dust. The solar wind limb glow. Mars has a strange way of interacting with the sun. Because it lacks a global magnetic field, the solar wind slams directly into the upper atmosphere. This creates a limb glow, a faint, ultraviolet light that wraps around the edge of the planet. While we understand the basic physics, the intensity and timing of the glow often defy predictions. Sometimes the atmosphere puffs up unexpectedly, and the glow extends much farther into space than it should. It is as if the planet is reacting to the sun in a rhythmic, almost organic way, shedding its atmosphere in pulses that we still cannot accurately forecast. The tropical frost of Valles Marineris. Deep within the grandest canyon in the solar system, Valles Marineris, a strange phenomenon occurs every Martian morning. As the sun rises over the jagged cliffs, a thin, brilliant layer of water frost appears on the canyon floor and along the caldera rims of the nearby volcanoes. What makes this a mystery is the location. These are the tropics of Mars, where the air is supposed to be too dry and the sun too intense for frost to form. Scientists recently discovered that the local microclimate within the canyon acts as a cold trap, funnily enough, moving water vapor across vast distances to deposit it in these specific spots. It is a delicate, fleeting water cycle that suggests Mars is much more humid than its red, dusty reputation suggests. The strange case of the missing dust devils. On Earth, we can predict when and where dust devils will form based on heat and wind. On Mars, we see thousands of these dust ghosts through our orbital cameras, spinning columns of red sand that reach kilometers into the sky. However, in certain regions that seem perfect for them, like the vast plains of Elysium Planitia, they are almost entirely absent. Conversely, in other areas, they appear in such density that they crisscross the entire landscape with dark, etched tracks. We still don't fully understand the soil chemistry or the specific thermal properties of the Martian ground that allow one field to be alive with spinning storms while another, identical field remains deathly still. The holes of the Tharsis Plateau. The Tharsis region is home to the largest volcanoes in the solar system, but its most unsettling features are the Seven Sisters, a series of deep, black pits discovered on the slopes of the volcano Pavonis Mons. Unlike the skylights of Arsia Mons, these pits appear in a straight line, as if something beneath the surface has been systematically collapsing. These holes are doorways into a subterranean world we haven't even begun to map. Because Mars is geologically dead on the surface, these deep volcanic caverns might still hold internal heat, potentially creating pockets of warmth where liquid water, and perhaps life, could have retreated as the surface became a frozen wasteland. The mystery of the Martian spiders in the north. While we talked about the spiders in the south, the northern hemisphere of Mars has its own version, but they look entirely different. Instead of spindly, dark legs, the northern spiders appear as polygonal cracks and strange, white-rimmed mounds. They look like a giant's jigsaw puzzle spread across the polar plains. Geologists believe this is caused by permafrost contraction, the ground freezing and shrinking over thousands of years, but the mathematical precision of the hexagons and the way they change color with the seasons suggests a complex interaction between the soil ice, and atmosphere that we can't quite replicate in our planetary models. The drip features of Richardson Crater. In Richardson Crater, near the South Pole, there are features that look like dark, viscous liquid dripping down the dunes. These flows are much wider and slower than the recurring slope lineae we find at the equator. They appear to be defrosting in slow motion. The mystery is the substance. Some believe it is a slurry of melting CO2 ice and sand, but others suggest it could be a solid-state greenhouse effect, where sunlight trapped under the ice melts a thin layer of liquid water even when the air temperature is well below freezing. These dark drips are a visual reminder that the Martian surface is constantly bleeding gases and fluids in ways we are still trying to map. The high-altitude plumes of 2012. In 2012, amateur astronomers noticed a colossal plume rising from the edge of the Martian disk, reaching over 200 kilometers into space. This was twice as high as any known cloud or dust storm. It persisted for weeks before vanishing. NASA's best scientists were baffled. At that altitude, the atmosphere is virtually non-existent, and there shouldn't be enough material to reflect light so brightly. Was it a massive volcanic outgassing from a dead volcano? A collision with a large, unseen comet? Or a localized auroral display of unprecedented scale? To this day, the plume of 2012 remains one of the most significant unexplained atmospheric events in Martian history. The Martian cauliflower rocks. The Spirit rover discovered something truly bizarre in the home plate region of Gusev Crater. Small, knobby outcrops of silica that look remarkably like heads of cauliflower. On Earth, these specific types of silica structures are almost exclusively formed by hot springs, where microbes play a role in the mineral deposition. While it's possible for chemistry to do this alone, the cauliflower rocks are one of the most tantalizing pieces of evidence for ancient hydrothermal vents on Mars, the very places where life is thought to have started on Earth. If these rocks were formed by hot water, they might be the fossilized remains of the first Martian oases, the vanishing magnetic islands. While Mars has no global magnetic field, it has crustal magnetism, small patches of the ground that are still highly magnetized. Curiously, orbiters have noticed that the strength of these magnetic islands seems to fluctuate. This shouldn't be possible. Magnetism in rocks is usually permanent unless the rock is heated to extreme temperatures. Some researchers suggest that the electrical environment of Mars, the way the solar wind interacts with the surface, might be temporarily amplifying or dampening these magnetic signals. It's as if the planet's ghost shield is trying to flicker back to life in localized, mysterious pulses. The white clouds of Olympus Mons. Every afternoon, a massive white cloud forms over the peak of Olympus Mons, the tallest mountain in the solar system. This cloud is so large it can be seen from Earth with a decent telescope. It is an orographic cloud, formed when air is pushed up the slopes of the volcano. However, the mystery is the timing and the composition. Despite the atmosphere being nearly void of water, this cloud is consistently lush and bright. It suggests that the massive volcano is still acting as a wick, drawing what little moisture exists in the atmosphere toward its summit, creating a lonely, white crown on a red giant. The dune forest of the north. In the far north, there are vast fields of dunes that, from a distance, look like they are covered in a dense, dark forest of trees. Upon closer inspection, these trees are actually dark streaks of sand cascading down the frost-covered slopes of the dunes. This happens when the winter ice begins to sublimate, causing the dark sand beneath to burst out and slide down the face of the dune. The illusion of a forest is so convincing that it has sparked countless urban legends, but the scientific reality, a planet that literally exhales its sand through its ice, is perhaps even more mysterious. The green airglow, one of the most ethereal mysteries of the Martian night, was only recently confirmed by orbiting spacecraft. If you were to stand in the pitch-black darkness of a Martian crater and look up, you might see a faint, ghostly green shimmer hanging in the upper atmosphere. This isn't an aurora caused by solar particles, but a phenomenon called airglow. On Mars, it happens when oxygen atoms, which have been split apart by sunlight on the day side, drift to the night side and recombine. As they pair back up, they release a soft, emerald light. The mystery lies in the intensity. The glow is much brighter than atmospheric models predicted, suggesting that the chemistry of the Martian edge of space is far more active and energetic than we once believed. The blue rocks of Mount Sharp. As the Curiosity rover climbed the slopes of Mount Sharp, it sent back images of a field of stones that looked completely out of place. Amidst the endless orange and red dust were smooth, dark rocks with a distinct, metallic blue tint. When scientists analyzed them, they found they were high in magnesium and iron, similar to volcanic basalt, but their texture was unusually glassy. Some speculate these blue rocks were polished by eons of wind-driven sand, while others wonder if they were formed in an ancient, high-energy underwater environment. They sit like discarded sapphires on a rusted world, a chemical anomaly that tells a story of a very different, more colorful Martian past. The mystery of the Great Galactic Ghoul. For decades, Mars earned a reputation as a graveyard for spacecraft. During the early era of exploration, nearly two-thirds of all missions to the Red Planet failed, often for reasons that seemed inexplicable. Engineers jokingly blamed the Great Galactic Ghoul, a mythical space monster that supposedly preyed on Martian probes. While most failures were eventually traced to math errors or hardware glitches, a few remains truly mysterious: transmissions that cut out mid-descent with no mechanical warning, or orbiters that simply vanished into the void. This high failure rate highlights how difficult it is to touch Mars, as if the planet itself resists being known by outsiders. The polar Swiss cheese terrain. Near the South Pole, the Martian landscape takes on a bizarre, porous appearance that astronomers have nicknamed Swiss cheese terrain. It consists of circular pits and mesas carved into a thick layer of carbon dioxide ice. These pits are constantly growing and changing shape, expanding by several meters every Martian year. The mystery is the rhythm of this erosion. In some years, the pits grow perfectly uniformly. In others, they lopsidedly melt in one direction. Because this ice is made of dry ice, frozen gas, the terrain is essentially evaporating into the atmosphere, making it one of the most rapidly changing landscapes in the solar system. The argon accumulation. Argon is a noble gas, meaning it doesn't react with other elements. Because it's heavy, it tends to settle in the lowest parts of the atmosphere. Curiously, during the Martian winter, scientists have observed a massive buildup of argon over the poles, far more than can be explained by simple atmospheric mixing. It's as if the planet is exhaling argon as the carbon dioxide freezes out. This seasonal surge creates a localized chemical environment that is completely different from the rest of the planet. Why the argon concentrates so heavily in specific pockets, rather than spreading out, remains a puzzle for atmospheric physicists. The solar wind plucking. Because Mars has no global magnetic field, the solar wind, a stream of charged particles from the sun, interacts directly with the upper atmosphere. Scientists have observed a process they call plucking, where the solar wind literally grabs chunks of the Martian atmosphere and flings them into deep space. The mystery is the efficiency of this process. Some data suggests that during solar storms, Mars loses its atmosphere at a rate that should have stripped the planet bare billions of years ago. Yet, a thin veil of air remains. This implies there may be a hidden source of gas, perhaps from deep underground, that is slowly refilling the atmosphere even as the sun tears it away. The disappearing hydrated salts. The search for liquid water on Mars often leads to hydrated salts, minerals that have trapped water molecules inside their crystal structures. Orbiters have detected these salts in many locations, but when rovers actually arrive to inspect the sites, the signals often seem to disappear or shift. This "now you see it, now you don't" mineralogy suggests that the surface of Mars is chemically fickle. The salts may be absorbing moisture from the air at night and releasing it during the day, changing their chemical signature in a matter of hours. It makes the hunt for water a game of cat and mouse with the Martian sun. The Inca City. Deep in the southern highlands lies a series of intersecting ridges that look so much like the ruins of a mountain fortress that they were named Inca City. The ridges are remarkably straight and meet at near right angles, forming a grid-like pattern over several kilometers. While geologists believe these are clastic dikes, cracks in the ground that were filled with lava or soft sediment that later hardened and was exposed by erosion, their architectural appearance is stunning. They stand as a testament to how natural forces on Mars can mimic the deliberate geometry of a lost civilization, creating a ghost city made of stone and shadow. The mystery of Martian lightning. For years, scientists debated whether the massive dust storms on Mars could generate static electricity and lightning. On Earth, lightning requires moisture, but on Mars, it would be dry lightning born from the friction of billions of sand grains rubbing together. In 2009, researchers detected microwave signals from a Martian storm that matched the signature of electrical discharges. However, we have yet to capture a bolt on camera. If Martian lightning exists, it would be a dim, purple-blue glow inside the red clouds. A silent, crackling energy that could be responsible for creating the strange chemistry we see in the Martian soil. The twin craters of clear lakes. In certain regions of Mars, there are pairs of impact craters that are nearly identical in size and shape, sitting side by side as if they were stamped onto the surface at the same time. These binary craters suggest that the asteroids hitting Mars often come in pairs or break apart just before impact. The mystery is why this seems to happen more frequently on Mars than on the Moon or Earth. It suggests that the space surrounding Mars might be littered with rubble pile asteroids, loose clusters of rock held together by weak gravity that split apart the moment they feel the tug of the red planet. The frozen waves of Vestidas Borealis. In the far northern plains of Mars, there is a region that looks as though a giant ocean was frozen mid-storm. These frozen waves are actually vast, undulating ridges of ice and soil that stretch for hundreds of kilometers. The mystery lies in their origin. They don't follow the typical patterns of wind-blown dunes or volcanic flows. Some scientists propose they are the remnants of a mega tsunami from billions of years ago, triggered when a massive asteroid slammed into a northern ocean, sending walls of water crashing into the highlands. As the planet cooled, these catastrophic ripples were locked in place, a permanent memorial to a day the Martian ocean tried to escape its basin. The dust towers. During global dust storms, researchers have observed a terrifying phenomenon: dust towers. These are concentrated, massive clouds of dust that are much denser than the surrounding storm, rising like skyscrapers up to 80 kilometers into the air, nearly the edge of space. These towers act like giant elevators, lifting water vapor from the surface and dumping it into the upper atmosphere where the sun can destroy it. The mystery is how these towers maintain their narrow, vertical structure without being shredded by high-altitude winds. They are the primary suspects in the ongoing theft of Mars water, acting as conduits that slowly bleed the planet dry. The mystery of the bright pit. Deep within the shadow-filled canyons of the Noctis Labyrinthus, orbiters found a single pit that glowed with an intense, unexplained brightness. While most Martian pits are black voids, this one was filled with a brilliant, reflective material. Spectral analysis suggests it might be a rare form of sulfate or even exposed water ice that has somehow remained fresh and untarnished by red dust. How a single pit in a massive labyrinth could remain so clean and reflective while the rest of the planet is covered in rust, is a geological anomaly that suggests recent activity. Perhaps a localized burp of water or gas that washed the walls clean. The missing small craters. When astronomers look at the youngest surfaces on Mars, they notice a statistical impossibility. There aren't enough small craters. According to the history of the solar system, for every giant impact, there should be thousands of smaller ones. On Mars, the small craters seem to have been erased. While wind and dust can cover them over millions of years, the rate at which they are disappearing is much faster than our weather models allow. This suggests that the Martian surface is much more active than it looks, with a mysterious process, perhaps ice creep or microseismic activity, constantly smoothing out the smaller dents in its armor. The greenish night glow oxygen. In addition to the emerald airglow we discussed, there is a specific type of oxygen night glow that only appears in the Martian tropics. This glow is seasonal and follows a rhythm that doesn't match the sun's activity. Some researchers believe it is linked to the way the Martian atmosphere breathes over the massive Tharsis volcanoes. As the volcanoes push air upward, it creates chemical reactions in the upper atmosphere that produce this specific green hue. It is a reminder that even though the volcanoes are dormant, their sheer physical presence still dictates the chemistry of the sky above them. The sinuous ridges of Chryse. The Chryse Basin is home to long, winding ridges that look like ancient, petrified snakes stretching across the valley floor. These are known as eskers. On Earth, eskers are formed by tunnels of water flowing underneath massive glaciers. If these are truly eskers, it means the Chryse Basin was once covered by a glacier the size of a continent, with entire river systems flowing in secret beneath the ice. The mystery is the timing. These ridges look relatively young, suggesting that Mars might have had massive, localized glacial periods much more recently than we ever suspected. The Donut Rock. The Opportunity rover once famously discovered a rock that appeared out of nowhere. One day the ground was empty. The next, a small, white-rimmed rock with a red center, looking exactly like a jelly donut, was sitting in front of the rover. After weeks of speculation about alien mushrooms or volcanic vents, NASA concluded the rovers had simply flicked the rock into view. However, the rock's chemistry was the real mystery. It was higher in sulfur and manganese than anything ever seen on Mars. It was a homeless rock, a chemical stranger whose origin point on the planet remains undiscovered. The glowing ghost peaks of the south. During the transition from autumn to winter, the peaks of the southern mountains sometimes appear to glow in thermal infrared images, staying much warmer than the surrounding valleys. Usually, mountaintops should be the first to cool down. This thermal inversion suggests that the mountains might be trapping pockets of a thicker, warmer atmosphere, or that there is a heat-retentive material, possibly high-density metallic ores, exposed on the summits. For a few weeks a year, these mountains stand like glowing embers in the dark, cold polar night. The strange polygons of Utopia Planitia. Utopia Planitia is a vast, flat plain, but if you look closely at the soil, it is cracked into perfect giant polygons, some kilometers wide. These look identical to the freeze-thaw patterns found in Earth's Arctic regions. The mystery here is the scale. On Earth, these patterns are small. On Mars, they are gargantuan. This suggests that the Martian permafrost is kilometers thick and has undergone massive, planet-wide shivers, where the entire crust expanded and contracted, creating a geometric web that covers an area larger than the Sahara Desert. The mystery of the chocolate hills. In certain regions of the Martian lowlands, there are clusters of thousands of small, conical mounds that look strikingly like the chocolate hills of the Philippines. These rootless cones are thought to form when lava flows over wet ground or ice, causing steam explosions that blast mounds of debris into the air. If this is the case, it means that at one point, Mars was a chaotic landscape of fire and ice, with molten rock and frozen oceans clashing in a series of steam-driven eruptions that shaped the very ground we see today. The blue dunes of Lyot Crater. Deep within the Lyot Crater, located in the northern lowlands, lies a field of sand that defies the planet's rusted reputation. While most of Mars is covered in iron oxide dust, these specific dunes appear in a striking turquoise blue. They are made of a different kind of sand, complex, basaltic grains that are heavier and more chemically pristine than the surrounding dust. The mystery is why they are concentrated here. It is as if the Lyot Crater acts as a giant centrifugal separator, sorting the dark, volcanic minerals from the red rust and piling them into these beautiful, cerulean waves. They look like an ocean trapped in a crater, a cool blue oasis in a world of fire-toned stone. The moving white streaks. In the vast, open plains, orbiters have captured images of brilliant white streaks that appear to crawl across the ground over the course of several Martian years. Initially thought to be clouds or frost, they are actually deposits of a highly reflective material, likely a salt or carbonate, that are being pushed by the wind. However, the streaks move in directions that often contradict the prevailing wind patterns recorded by our rovers. This has led to the theory that they are being moved by slope winds or even electrostatic levitation, where the thin air and dry dust create enough of a charge to lift the white minerals and let them dance across the surface in a slow-motion migration. The secret lake of the South Pole. In 2018, radar data from the Martian instrument suggested the presence of a massive, 20-kilometer-wide lake of liquid water buried 1.5 kilometers beneath the southern polar ice cap. On a planet where liquid water should be impossible, this was a bombshell. However, the mystery deepened when subsequent studies suggested that for water to remain liquid under that much ice, it would have to be incredibly salty, a brine far saltier than Earth's oceans, or heated by a hidden volcanic chamber. To this day, scientists debate whether the radar signal is truly water or just a very specific reflective type of clay. If it is a lake, it is the most significant potential habitat for life ever found on another planet. The mystery of the spiral polar chasma. At the North Pole of Mars, the ice isn't a flat cap. It is carved into a series of massive, swirling spiral troughs. From above, it looks like a giant white hurricane frozen in time. These canyons, known as chasma boreal, are kilometers deep. The mystery is how they stay so perfectly spiraled. Computer models suggest they are formed by a combination of katabatic winds, heavy, cold air falling off the pole, and the Coriolis effect from the planet's rotation. But the precision of the spiral and the way it has remained stable for millions of years suggests a delicate balance of climate forces that we are only beginning to simulate. The Taffy lava flows. In the Daedalus Planum region, there are volcanic flows that look less like rock and more like pulled taffy or folded blankets. These labate flows have strange, ropey textures that suggest the lava was incredibly thick and moved with the consistency of cold honey. However, Martian volcanoes usually erupt thin, runny basalt. The mystery is what could have made the lava so viscous. Was it a different chemical composition? Or did the lava flow over massive underground ice deposits, cooling so rapidly that it folded over itself in these bizarre, architectural shapes? They are monuments to a period of slow-motion volcanism that reshaped the planet's crust. The high-altitude spider geysers. While we know the spiders are formed by gas escaping from beneath the ice, recent observations have caught something even stranger: the geysers themselves. During the spring, columns of dark dust and gas shoot hundreds of meters into the thin air. These geysers appear and disappear in a matter of hours. The mystery is the trigger. Sometimes the ice cracks in a peaceful hiss. Other times, it seems to explode with the force of a small bomb. We still don't know what determines the violence of the Martian spring. or if these geysers carry trace gases from deep within the soil that could tell us if life is exhaling beneath the ice. The inverted craters of Arabia Terra. In the Arabia Terra region, there are features that look like craters, but instead of being holes in the ground, they are raised mounds that stand high above the plains. These are inverted craters. They form when a crater is filled with hard, erosion-resistant material, like volcanic lava or water-hardened minerals, and the softer surrounding land is blown away by the wind over billions of years. The mystery is what filled them. If it was water, then Arabia Terra was once a land of thousands of circular, sparkling lakes. If it was lava, it was a landscape of fire. These mounds are the negative space of ancient history, standing as pedestals for a past that has been blown away. The mystery of the Martian snow. For years, we wondered if it actually snowed on Mars. We finally saw it with the Phoenix lander. But the snow was unlike anything on Earth. Because the atmosphere is so thin, the water ice snow crystals often evaporate before they even hit the ground, a phenomenon called virga. But in the deep winter, it also snows carbon dioxide, dry ice. This CO2 snow falls in tiny, cubical crystals, creating a landscape that would look like it was covered in sparkling, microscopic diamonds. The mystery is the snowfall rate. We don't know if Mars experiences blizzards, or if the snow just falls in a constant, silent, crystalline mist. The Gorgonum Chaos. The Gorgonum Chaos is a region of Mars that looks like a shattered mirror. It is a jumble of blocky hills, deep troughs, and chaos terrain, where the crust has simply collapsed. This area is famous for its gullies, features that look like they were carved by flowing water just yesterday. The mystery is the age of these gullies. Some appear to have formed over existing tracks, suggesting that liquid events are still happening in this chaotic region. Is there a hidden aquifer beneath Gorgonum Chaos that occasionally bursts and spills down the cliffs? Or is this the work of melting snow in a very specific, protected microclimate? The face of the South Pole. While the Cydonia face is the most famous, the South Pole has its own pareidolia mystery. In certain lighting, a series of pits and hills in the ice creates a perfect happy face crater, complete with two eyes and a wide, grinning mouth. Beyond the humor of the image, the mystery is its geological resilience. Most features in the polar ice are eroded or changed by the shifting seasons, but the grinning crater has remained stable for decades. It is a reminder that even in the most hostile, freezing environments of the solar system, the random forces of erosion can create shapes that feel uncannily familiar to the human eye. The beaded ridges of the equatorial plains. In the flat, dusty expanses near the Martian equator, there are long, narrow ridges that look like strings of pearls draped across the landscape. These beaded ridges consist of small, uniform mounds spaced at regular intervals along a central spine. Geologists are divided on their origin. Some believe they are fossilized terminal moraines, the debris left behind by a glacier that retreated in pulses. Others suggest they are volcanic pit chains, where lava tubes collapsed in a rhythmic pattern. The mystery is the perfect spacing. Nature rarely produces such mechanical regularity unless there is a deep, underlying cycle of pressure and release that we have yet to witness in action. The hidden glaciers of the mid-latitudes. Mars is famous for its polar ice, but one of its greatest secrets is the ice hiding in its waistline. Radar data has revealed that beneath thick blankets of red dust in the mid-latitudes lie massive, buried glaciers, some hundreds of meters thick. These are not just small patches. They are lobate debris aprons that contain enough water to cover the entire planet in a shallow ocean. The mystery is how they have survived for millions of years without evaporating. The dust armor must be perfectly tuned to insulate the ice. These hidden glaciers are the time capsules of Mars, likely containing air bubbles from ancient atmospheres, preserved in a dark, cold tomb, the spiders that don't move. While we've discussed the active geysers that create spider-like patterns, there are regions on Mars where these spiders appear to be etched permanently into the rock itself. Unlike the seasonal patterns that fade, these are deep, dendritic canyons that follow the exact same arachnid geometry. This suggests that the process of CO2 gas erosion has been happening in the exact same spots for millions of years, slowly carving the solid bedrock into a maze of spindly legs. Why the gas chooses the same exit points eon after eon, perhaps following ancient volcanic veins, remains a mystery of Martian plumbing. The mystery of the white bacon strips. In the Schiaparelli crater, there are alternating layers of light and dark material that, from orbit, look remarkably like strips of bacon. These are sedimentary layers that have been tilted and eroded, but the mystery is their rhythm. The layers are almost identical in thickness, suggesting a cyclical climate event that repeated with perfect precision every few thousand years. On Earth, such patterns are often linked to the wobble of the planet's axis. Because Mars wobbles much more violently than Earth, these bacon strips may be a recording of a time when the Martian climate flipped from icehouse to greenhouse in a rapid, repeating cycle. The dust-covered holy rocks. When the Spirit rover explored the Gusev crater, it found rocks that were filled with small, smooth holes, looking like a sponge made of stone. These are called vesicular rocks, usually formed when gas bubbles are trapped in cooling lava. However, many of these holes were filled with a bright, white, chalky substance. Analysis showed it was a mix of magnesium and iron sulfates. The mystery is how the stuffing got inside. It suggests that long after the lava cooled, mineral-rich water soaked into the rocks and evaporated, leaving behind these white plugs. It is evidence of a soaking period in Martian history that was far more widespread than we once thought. The mounds of Gale Crater. Inside the crater where the Curiosity rover resides, there are thousands of small, dark mounds scattered across the floor, looking like a field of giant molehills. These Heisler mounds are made of a material that is much darker and denser than the surrounding sand. Some think they are spring mounds, created when groundwater bubbled up to the surface, depositing minerals as it evaporated. Others believe they are wind-sculpted remnants of an older, lost floor. If they are spring mounds, they represent thousands of individual vents, where liquid water once reached the surface, making the crater floor a graveyard of ancient oases. The ghostly halo craters. In the transverse Aeolian ridges, there are impact craters surrounded by a bright, glowing halo that is only visible in certain wavelengths of light. This halo isn't made of ejected rock, but of a change in the grain size of the dust surrounding the impact. Somehow, the shock wave of the asteroid hitting the ground permanently altered the physical properties of the dust for kilometers around, making it reflect light differently. These halos persist for millions of years, long after the crater itself has begun to fill with sand, standing as ghostly reminders of the energy of the impact. The blueberry clusters that defy gravity. While the individual blueberries, hematite spheres, are a known mystery, rovers have recently found clusters of them that are fused together in strange, branching shapes that look like coral. These blueberries shouldn't be able to fuse this way through simple geological pressure. This has led to the biosignature debate. On Earth, such branching mineral structures are often created by colonies of bacteria. While most geologists prefer a chemical explanation involving wicking water, the visual similarity to biological growth keeps the question of ancient Martian microbes on the table. The mystery of the slushy flow. In the Malaz Chasma, part of the Great Canyon system, there are flows that look neither like liquid water nor like dry sand. They have a slushy appearance, with rounded edges and a texture that suggests a high-viscosity fluid. Some researchers have proposed dry flows lubricated by a thin layer of gas, while others wonder if these are mud flows from a time when the Martian interior was much warmer. The way they wrap around obstacles without splashing suggests a slow, silent movement. A river of mud that moved through the canyons with the stealth of a glacier but the speed of a stream. The polished rocks of the northern plains. In the far north, the rocks aren't jagged or rough. They are incredibly smooth and polished, reflecting the sunlight like a mirror. This desert varnish is common on Earth, but on Mars, it covers almost every exposed stone in certain regions. The mystery is the polishing agent. In an atmosphere so thin, wind alone shouldn't be able to buff a rock to a mirror finish. This suggests a chemical process, perhaps a microscopic film of water that forms every morning and chemically sands the rock, or a specialized type of dust that acts as a natural polishing compound. The green olivine beaches. In the Neely Fosse region, Mars reveals one of its most vibrant secrets: vast stretches of green sand. These aren't made of organic matter, but of a mineral called olivine, the same stuff that makes up the gemstone peridot. On Earth, olivine is quickly destroyed by water and oxygen, turning into clay. The fact that Mars has beaches of pristine green olivine suggests that for billions of years, this region has been deathly dry. However, right next to these green sands are ancient carbonate rocks that require water to form. The mystery is how these two opposites exist side by side. A landscape that proves it was once soaking wet, and a mineral that proves it has been bone dry ever since. The carbon-12 anomaly. When the Curiosity rover drilled into the 3.5-billion-year-old mudstones of Gale Crater, it found something that sent a shiver through the scientific community: an enormous depletion of carbon-13 and a surplus of carbon-12. On Earth, this specific light carbon signature is the smoking gun for biological life, as bacteria prefer to use carbon-12 for their metabolic processes. While it's possible that this signature was caused by ultraviolet light interacting with CO2 or even the solar system passing through a giant molecular cloud long ago, the simplest explanation is the most haunting. We may have found the chemical leftovers of an ancient Martian lunch. The mystery of the fossil magnetic stripes. When Mars crustal magnetism was first mapped, scientists noticed a pattern that looked remarkably like the magnetic stripes found on the Earth's ocean floor. On Earth, these stripes are proof of plate tectonics, the movement of the crust as it spreads and creates new land. Mars, however, is thought to be a one-plate planet with no tectonic movement. If these stripes are real, it means Mars once had a shifting, moving crust just like Earth. It would mean the red planet wasn't always a stagnant desert, but a world of moving continents and deep-sea trenches that has since frozen in place. The white rock of Pollock Crater. Inside the Pollock Crater lies a feature so bright it can be seen from incredible distances. A massive, white, eroded mound that sits in the middle of a dark, basaltic floor. Early observers thought it might be a giant salt deposit or even an ice sheet, but modern analysis shows it is a unique type of compacted dust or volcanic ash that has a compactedness found nowhere else on the planet. The mystery is why it formed in this one specific spot. It's as if a giant, white beacon was placed inside a dark bowl, resisting the wind and the dust for billions of years while everything around it was ground to a powder. The strange brain terrain. In the mid-latitudes, there is a type of landscape that looks exactly like the surface of a giant gray human brain. Known as brain terrain, it consists of complex, winding ridges and grooves. Geologists believe this is caused by the slow creep of ice buried just beneath the soil. As the ice flows and sublimates, it warps the ground above it into these organic-looking lobes. The mystery is why it only forms in specific bands of latitude. It is a visual representation of the hidden Mars, a world where the most interesting activity is happening just out of sight, beneath a thin skin of dirt. The mounds of Acidalia planitia. Acidalia planitia is famous as the landing site in The Martian, But the real mystery of the region is its thousands of giant mounds. These aren't dunes or hills. They look like mud volcanoes. On Earth, mud volcanoes form when gas and water are trapped deep underground and burp to the surface. If these are mud volcanoes, it means there is a massive, pressurized reservoir of liquid mud and gas deep beneath the Martian surface. It suggests that Acidalia is not a dead plain, but a sleeping geological giant that could erupt with a slurry of ancient mud at any moment. The mystery of the missing sulfur. Mars is an incredibly sulfur-rich planet. The dust is full of it. However, when we look at the oldest rocks on the planet, the sulfur is strangely absent. It only appears in massive quantities in the middle era of Martian history. This suggests a planet-wide sulfur vent, possibly caused by a period of extreme volcanic outgassing that choked the atmosphere with sulfur dioxide. This would have created acid rain on a global scale, turning the Martian oceans into giant vats of battery acid. The mystery is what triggered such a sudden, violent change in the planet's chemistry. The ghost craters of the Northern Sea. Beneath the smooth, flat dust of the northern lowlands lie ghost craters, impact sites that have been completely buried by kilometers of sediment. We can only see them through gravity maps and deep penetrating radar. These craters prove that the northern hemisphere was once just as scarred and rugged as the south. The mystery is what filled the north so perfectly. Was it a slow accumulation of dust over eons, or was it a catastrophic, rapid filling by a northern ocean that dumped billions of tons of sediment in a geological heartbeat? The T-Rex footprint. In the Yanni Chaos region, there is a depression that looks exactly like a giant, three-toed footprint of a dinosaur, spanning several kilometers. While clearly a product of chaos terrain collapse, its shape is so perfect it has become a mascot for the weirdness of Martian erosion. The mystery behind it is the catastrophic release of water that likely caused it. Geologists believe the entire region collapsed when an enormous underground aquifer suddenly drained, causing the land to fall into the empty space. The footprint is actually a hole left behind by a disappearing sea, the pulsing auroras. Mars does not have a northern lights like Earth because it lacks a global magnetic field. Instead, it has discrete auroras that pulse over the magnetic islands in the southern hemisphere. These auroras are invisible to the human eye, appearing only in ultraviolet light. The mystery is their behavior. They don't just glow, they flash and pulse in sync with the solar wind. They are like localized lights that cling to specific rocks on the surface, a fragmented, ghostly version of a magnetic shield that exists only in patches. The methane rhythms. As the Martian seasons shift from spring to summer, a mysterious pulse ripples through the atmosphere. The Curiosity rover has recorded a seasonal cycle where methane levels peak in the late summer and drop in the winter. On Earth, this is the literal heartbeat of a biosphere, life waking up in the warmth and going dormant in the cold. While it could be caused by clathrates, ice cages that trap gas and release it as they melt, the timing is so precise it mimics the behavior of a living planet. We are left with a haunting question. Is Mars breathing, or is it just the rhythm of stones and ice mimicking the patterns of life? The deep life hypothesis. If life ever existed on Mars, it likely fled the surface billions of years ago. The mystery now lies in the deep biosphere. On Earth, microbes live kilometers below the crust, thriving on the heat from the core and chemical energy from rocks. Mars' interior is still warm, and its crust is thick enough to shield life from the sun's radiation. This means that while the surface is a frozen desert, a few miles down, there could be vast, dark networks of liquid water. The ultimate mystery of Mars may be that we are looking for life on the wrong side of the ground. The mystery of the fossilized raindrops. In certain ancient clay deposits, geologists have found tiny, circular pits that look identical to the raindrop impressions found in Earth's mudstones. If these are truly raindrops, they are a physical impossibility for the modern Mars. They would prove that the ancient atmosphere was thick enough for water to fall as liquid rain rather than snow. This implies a warm and wet early Mars that was almost indistinguishable from the early Earth. These tiny dents in the mud are the whispers of a world that once had a sky full of clouds and the sound of falling water. The ogle of the Grand Canyon. The Valles Marineris is so large that it spans the entire width of the United States. But its greatest mystery is its birth. It isn't a river canyon like the Grand Canyon on Earth. It is a giant crack in the planet's crust. It appears to have been ripped open as the Tharsis volcanoes grew. But the amount of material missing from the canyon is staggering. Where did all that rock go? Some scientists believe it was washed away by catastrophic outflow floods that were so powerful they could have filled an entire ocean in a matter of days, leaving behind a scar that can be seen from the other side of the solar system. The strange case of the Hesperian transition. There is a specific point in Martian history where the planet changed almost overnight. It went from a world of lakes and rivers to a world of acidic, sulfurous seas and freezing deserts. This period, called the Hesperian transition, remains one of the greatest whodunits in planetary science. Was it a massive volcanic eruption that poisoned the air? A change in the planet's tilt? Or did the magnetic field finally die, leaving the world defenseless? This death of a world is a cautionary tale written in the layers of Martian stone. The Martian dunes that sing. On Earth, certain sand dunes produce a low-frequency hum or a booming sound when sand slides down their faces. On Mars, the conditions are perfect for singing sands. Because the sand grains are so uniform and the air is so thin, the vibrations of moving sand would create an eerie, acoustic drone. We have yet to record this song directly, but physics suggests that if you were standing near the dunes of the Hesperian plains, you wouldn't just see the wind, you would hear the planet itself vibrating in a deep, lonely chord. The mystery of the blue clouds. While most Martian clouds are white or gray, noctilucent clouds have been spotted high in the twilight sky that glow with a brilliant, electric blue. These clouds form at the very edge of space, where the atmosphere is so thin it's a near vacuum. They are thought to be made of CO2 ice crystals that scatter sunlight long after the sun has set below the horizon. They appear as glowing, blue threads in the dark, a mysterious second sunset that happens in the highest reaches of the atmosphere where nothing should be able to exist. The Darwin Rocks. The Perseverance rover recently discovered rocks in Jezero crater that are rich in olivine carbonate lithology. These rocks are significant because they are the same type found in Earth's Darwin Lost City, a hydrothermal field in the Atlantic Ocean. These rocks form through a process called serpentinization, which produces heat and hydrogen, the perfect fuel for microbial life. Finding these rocks on Mars means we have found a battery for life that could have been running for billions of years, long after the surface rivers dried up. The first Martians. One of the most profound mysteries is the theory of lithopanspermia, the idea that life can travel between planets via meteorites. We know Mars cooled down and became habitable long before Earth did. We also know that Martian rocks frequently hit Earth. This leads to the ultimate mystery. Is it possible that life started on Mars and seeded the Earth? If this is true, then we aren't looking for aliens when we go to Mars. We are looking for our ancestors. We might be the first Martians, finally returning to the world where our story actually began. The Ina Pit and recent volcanism. For decades, we believed the moon had been geologically dead for over 1 billion years. But then we discovered Ina. It is a D-shaped depression that looks remarkably fresh. It features smooth, round mounds sitting next to jagged, blocky terrain. Because there are so few impact craters on its surface, Some scientists suggest Ina might be less than 100 million years old. If this is true, it means the moon was erupting lava while dinosaurs were still walking the Earth. It challenges everything we thought we knew about how small worlds cool down, suggesting the moon might still have a warm, restless heart hidden deep beneath its cold exterior. The lunar caves and lava tubes. As our orbiters mapped the moon in high resolution, they found several skylights, perfectly circular holes in the surface that drop down into the darkness. These are the entrances to massive underground lava tubes, some of which are large enough to fit an entire city inside. These caverns are the ultimate sanctuary. They are shielded from the sun's radiation, the extreme temperature swings of the surface, and the constant rain of micrometeorites. The mystery lies in how many of these tunnels exist and whether they contain frozen volatiles or ancient volcanic gases, waiting in the silence for the first human explorers to step into the dark. The mystery of the water in the sun. In 2020, the Sophia Airborne Observatory detected water molecules on the sunlit surface of the moon, specifically in the Clavius crater. This was a shock to the scientific community. On the sunlit side, temperatures soar to over 100 degrees Celsius, which should cause water to evaporate and escape into space instantly. How is it staying there? Some believe the water is trapped inside impact glasses created by meteorites, while others think it might be chemically bound to the soil. It means the moon isn't just a dry rock. It is a world that somehow holds onto moisture even under the blistering heat of the sun. The lunar smell. Every Apollo astronaut who walked on the moon reported the same bizarre detail. Once they returned to the lunar module and took off their helmets, they smelled spent gunpowder. The lunar dust, or regolith, is highly reactive. Because it has been hammered by the solar wind and micrometeorites for billions of years, the grains are jagged and full of broken chemical bonds. When this dust meets the oxygen and moisture inside a spacecraft, it activates, creating a distinct, metallic scent. The mystery is how this reactive dust would affect human health over long periods, and why its scent is so universally described as the smell of a battlefield. The asymmetric crust. Gravity measurements have revealed that the moon's crust is significantly thicker on the far side than on the near side. This asymmetry is one of the moon's most enduring riddles. One theory suggests that Earth once had two moons, and the smaller one eventually collided with the larger one in a slow-motion crash, splattering its material across one hemisphere like a layer of thick icing. Another theory suggests that the Earth's intense gravity and heat during the moon's formation caused the magma ocean to crystallize unevenly. Regardless of the cause, the moon is a world out of balance, wearing a heavy coat on only one side. The mystery of lunar helium-3. The moon's soil is rich in an isotope called helium-3, which is incredibly rare on Earth. It is carried to the moon by the solar wind and trapped in the regolith over billions of years. Helium-3 is considered the holy grail of clean energy, as it could theoretically power nuclear fusion reactors without producing radioactive waste. The mystery isn't that it's there, but how we will ever harvest it. To get just 1 ton of helium-3, you would have to process millions of tons of lunar soil. The moon sits above us as a trillion-dollar gas station, a silent promise of a future energy revolution that we have yet to reach. The swelling of the moon. New data from the Lunar Reconnaissance Orbiter has shown thousands of lobate scarps, small cliffs that look like wrinkles on the surface. These scarps are young, meaning the moon is still physically changing. As the moon's interior continues to cool, the entire planet is shrinking like a drying raisin. This contraction causes the crust to snap and slide, creating thrust faults. The mystery is the frequency of these quakes. It suggests that the moon is much more tectonically active than its stagnant, cratered surface would lead us to believe. The moon is literally folding in on itself. The blue tones of the Maria. While the moon looks gray and white to the naked eye, High-saturation photography reveals that the dark seas, Maria, actually have distinct colors. Some are brownish red, while others are a deep, steely blue. These colors represent different concentrations of titanium and iron in the ancient lava. The blue Maria, such as the Sea of Tranquility, are exceptionally rich in titanium, more so than almost any volcanic rock found on Earth. Why some volcanic eruptions were so rich in rare metals while others were not remains a mystery of the moon's internal plumbing and its early molten history. The mystery of the Apollo 12 UFO. During the Apollo 12 mission, the astronauts reported a strange, flashing object that seemed to be tumbling through space near their command module. For years, this was a favorite story for conspiracy theorists. However, decades later, astronomers tracked an object called J002E3 and realized it was likely the spent third stage of the Apollo 12 Saturn V rocket. It had gone into a solar orbit and then, 30 years later, was captured back into Earth's orbit by a freak gravitational fluke. The mystery of the UFO was solved, but it revealed a new mystery: how the chaotic dance of gravity can bring our own ghosts back to haunt us years later. The Earth-Moon connectivity. We often think of the moon as a separate entity, but recent studies suggest our atmospheres might actually be touching. A geochorale of hydrogen atoms extends from Earth far past the orbit of the moon. This means that, in a sense, the moon is actually inside the outermost reaches of the Earth's atmosphere. Furthermore, when the moon passes through the Earth's magnetic tail every month, it is shielded from the solar wind and hit by Earth wind, oxygen ions from our own planet. We are literally breathing onto the moon once a month. A subtle chemical exchange between two worlds that have been dancing together for 4 billion years. The moon's hollow ring. When the Apollo 12 mission deliberately crashed its lunar module's ascent stage into the moon's surface to test seismic equipment, the result was one of the most famous and unsettling discoveries in lunar science. The moon did not just vibrate, it rang like a bell. The seismic waves continued for over an hour, a phenomenon that would be impossible on Earth, where the moist, complex crust dampens vibrations quickly. This led to fringe theories that the moon might be hollow. However, the scientific mystery is just as fascinating. The moon is so dry and its rocks so tightly packed that vibrations travel through it with almost zero loss of energy. It is a world of pure, rigid stone that echoes every footstep in a way that feels unervingly artificial. The magnetic anomaly of the Descartes Highlands. The Apollo 16 mission landed in the Descartes Highlands specifically to investigate why the ground there was so intensely magnetized. While the moon has no global magnetic field, the rocks in this region carry a magnetic signature stronger than almost anywhere else on the surface. The mystery is that there are no large iron deposits or obvious volcanic features to explain it. Some researchers suggest that a massive, metallic asteroid struck the opposite side of the moon, and the shockwaves traveled through the core, focusing all their energy on the Descartes Highlands and freezing a magnetic field into the rocks. It is a magnetic scar of a collision that happened on the other side of the world. The lunar spiders of the South Pole. Just as we found spiders on Mars, recent high-resolution images of the moon's South Pole have revealed strange, branching, dendritic patterns etched into the shadows of craters. However, unlike Mars, the moon has no carbon dioxide ice to sublimate. These lunar spiders are a complete enigma. Some scientists believe they are caused by electrostatic discharge, miniature lightning bolts that crawl through the lunar soil when the sun hits certain minerals after a long, cold night. If true, it means the lunar poles are electrically alive, crackling with invisible energy in the permanent dark. The mystery of the Ina marshmallows. The Ina crater, which we previously discussed as a site of recent volcanism, contains strange, rounded mounds that astronomers have nicknamed marshmallows. These mounds are smooth, reflective, and look almost soft compared to the jagged, cratered terrain around them. The mystery is their lack of dust. On a world where micrometeorites are constantly gardening the surface into a fine powder, these mounds look brand new, as if they were formed yesterday. This suggests that gas might still be seeping out of the ground, blowing the dust off these mounds and keeping them polished and clean, a sign that the moon is still exhaling. The missing volcanic water. When we look at lunar volcanic glass, we find tiny amounts of water trapped inside. This suggests that the moon's interior once held a surprising amount of moisture. However, when we look at the actual volcanic plains, the Maria, they are bone dry. Where did the water go? If the moon's mantle was wet, the surface should be covered in minerals that form in water, like clays or carbonates, but we find almost none. This water paradox suggests that either the water was stripped away by the vacuum of space with impossible speed, or the moon's interior is patchy, with some pockets of wet rock hidden inside a mostly dry world. The strange horizon glow of Surveyor 7. Long before humans walked on the moon, the robotic lander Surveyor 7 captured a series of images showing a distinct, thin line of light hovering just above the lunar horizon after sunset. Without an atmosphere, there should be no twilight. This horizon glow is thought to be a cloud of levitating dust held up by static electricity. But the mystery is the height. The glow was much higher than static electricity should be able to lift heavy dust grains. It suggests that the moon has a dynamic dust atmosphere that moves in waves across the Terminator line, a ghostly, floating desert that only appears in the half-light of dawn and dusk. The gravity holes. While mascons are areas of high gravity, the moon also has gravity holes, regions where the pull of the moon is unexpectedly weak. These are usually found in the lunar highlands. The mystery is that these holes don't always align with deep valleys or craters. This suggests that the moon's crust is fluffy or porous in certain areas, filled with massive underground voids or low-density rocks that we haven't yet identified. It makes navigating the moon's orbit a constant battle against an invisible, uneven landscape that tries to pull spacecraft off course. The iron sun effect. Space weathering is a process where the solar wind turns the lunar soil dark and red over time. But curiously, in some areas of the moon, the soil is turning metallic. Tiny nanophase iron particles are being created on the surface of dust grains, effectively coating the moon in a microscopic layer of pure iron. The mystery is why this happens more intensely in some craters than others. It suggests that the chemical makeup of certain lunar soils reacts more violently to the sun, meaning the moon is slowly plating itself in metal, one sunbeam at a time. The mystery of the backside mascons. We know the near side has mascons, mass concentrations, because of the large lava seas. But the far side, which has almost no lava, also has mascons hidden beneath its mountain ranges. This is a geological puzzle. If there was no lava to fill the craters and create dense rock, what is creating the extra gravity? It suggests that the far side was hit by much denser, heavier asteroids that didn't just crack the crust, but lodged themselves deep inside, remaining there as heavy ghosts that we can only detect through their gravitational pull. The lunar tattoo of the Apollo 11 landing site. When the Lunar Reconnaissance Orbiter took photos of the Apollo 11 landing site 40 years after the mission, the tracks left by the astronauts were still clearly visible. But there was something else, a bright, halo-like tattoo around the descent stage. This wasn't caused by dust being blown away, but by a permanent change in the way the soil reflects light. The rocket exhaust compressed the lunar soil in such a specific way that it changed its physical structure forever. It is a reminder that on a world with no wind and no rain, even a 5-second engine blast leaves a permanent mark, a human-made mystery that will last for millions of years. the mystery of the lunar oxygen. The moon's surface is a graveyard of oxygen, but it isn't in a form we can breathe. About 42% of the lunar soil, or regolith, is actually made of oxygen. It is chemically locked inside minerals like silica, magnesium, and iron oxides. The mystery lies in the extraction. While we know the oxygen is there, the chemical bonds are so incredibly strong that it requires massive amounts of energy. Temperatures over 900 degrees Celsius to break them. We are standing on a world that is nearly half composed of the very thing we need to survive, yet we are surrounded by a vacuum. It is a cruel irony of nature, a planet-sized tank of oxygen that is frozen into solid rock. The strange rocks of the Sea of Nectar. In the Mare Nectaris, astronauts and orbiters have spotted rocks that appear to be inverted. Usually, the heaviest minerals sink to the bottom of a magma ocean, while the lighter ones float to the top to form the crust. However, in the Sea of Nectar, we find dense, magnesium-rich rocks sitting right on the surface. This suggests a mantle overturn, a violent period in the moon's youth where its internal layers literally swapped places. The heavy guts of the moon rose to the surface, and the crust sank into the depths. Why this happened in such a localized, dramatic fashion remains one of the most significant puzzles of lunar evolution. The mystery of the cold lava. On Earth, lava is liquid because it is incredibly hot. But on the moon, we see evidence of irregular mare patches, IMPs, that look like they flowed very slowly, almost like a thick, cold sludge. These features have very few craters, suggesting they are young, but the moon shouldn't have been hot enough to produce lava so recently. This has led to the gas release theory. Perhaps it wasn't heat that made the rock flow, but a sudden release of high-pressure gas from deep underground that fluffified the dust and made it behave like a liquid. It would mean the moon's volcanoes aren't powered by fire, but by air. The Descartes magnetic shield. While we know the Descartes highlands are magnetized, recent studies suggest this magnetism actually created a mini-magnetosphere. For billions of years, this small patch of the moon had its own tiny version of Earth's northern lights and a protective shield against the solar wind. The mystery is how such a small area could maintain such a high magnetic intensity without a core to power it. It suggests that the moon's crust can act like a giant battery, storing magnetic energy from ancient, cataclysmic events and holding onto it for eons after the source is gone. The lunar dust fountains. During the Apollo missions, astronauts observed that their suits and equipment became coated in a fine, black dust that seemed to jump toward them. New research suggests that on the moon, the transition from day to night creates a massive electrical storm along the Terminator line. As the sun sets, the change in radiation causes the dust to become highly charged, creating dust fountains that spray particles kilometers into the sky. This isn't wind, it's a planet-wide electrical dance. The mystery is the granularity. Why only certain sizes of dust participate in this fountain, leaving the heavier grains behind? The mystery of the rusty moon. In 2020, the Chandrayaan-1 orbiter found evidence of hematite at the lunar poles. Hematite is a form of rust, and rust requires two things Mars has but the moon shouldn't: liquid water and oxygen. The moon has neither. The mystery of the rusty moon has led to a startling conclusion. The moon is being rusted by the Earth. Every month, when the moon passes through the Earth's magnetic tail, oxygen from our own atmosphere is blown onto the lunar surface. It is a haunting thought. Our own planet is slowly breathing on the moon, changing its chemistry from 250,000 miles away. As we pull our gaze back from the shimmering glass fields and the quiet, rusting craters of the moon, the silver glow begins to fade into a soft, velvety darkness. We have traveled across 100 mysteries of the red planet and ventured deep into the silent, shifting shadows of our own lunar neighbor. The cosmos is vast, and its secrets are many. But for tonight, your journey is complete. The distant echoes of moonquakes and the ghostly dance of levitating dust are now nothing more than a peaceful hum, lulling you into a deep and effortless rest. The stars will continue their silent watch, and the planets will keep their secrets, waiting for us to return when the sun rises again. But for now, there is only the stillness of your room and the heavy, comforting pull of sleep. Thank you for wandering the stars with Sleep with Stories. Close your eyes, let the universe drift away, and find peace in the quiet dark. Good night.